Okay. So this is the Kaggle dashboard. So you can log in with your Gmail account. Okay. So it's a universal login account. So this is the dashboard. Hope you are seeing the dashboard, right? Okay. So on the left pane, you can see that home, compositions, data sets, models, code, discussions, learn, a lot of things, right? So there are a lot of properties that you can use. At the same time, you can click the learn and you can do a lot of courses. Okay, whatever you want. Like so, there are a lot of courses here. There are guides. There are. I just completed two things, that is Python and data visualization. So there are a lot of things that you can learn yourself. It's all free. Just go in and do that, and it's very user friendly, right? And it once it doesn't take a lot of time and all. It's very short videos and it's very engaging. Huh? It's all free. It's all free. It's all free. It's all free. See, so the I will tell you why Kaggle is very important, because normally what you have to do is that you have to download and install Python. Okay, then you have to install Jupyter notebooks. Then you have to additionally install all the libraries and all things. That will take it very hectic work. Okay, so Python by itself, I'll tell you, it will not load by itself. By basic, it has got just the basic version. Then you will add all the libraries. They'll call for all the install all the libraries. So Kaggle, the thing is that it's very easy to install all these things. Just run a command and everything will run on the Kaggle platform. Okay. And another important thing is that it is device independent, right? So you want to use your Python at any system where you go for some laptop, desktop, you can do it on a SaaS platform. Okay, you don't need to go it into a installed version and do that. Okay, so that is why Kaggle is very famous. Okay, so it's a SaaS version basically. So you can do a lot of courses here. So I don't recommend this, because doing a course by itself doesn't make any sense unless until we have certain practical implications about that. Okay. So just click on home, just see that we have got data sets, notebooks, competition, discussions, courses. Okay. So let's go to data set. Okay. So click on data set, and then you can see that a lot of data sets are there. Okay. So competition data sets are there. My own data, these are all my own data sets. Okay. Right. So if you want to upload a new data set, just click on new data set and upload it. That's it. Okay, just click on upload data set and you just drop files here. Okay, that is how you upload it. You can upload XLS or CSV, whatever thing is that you want is like. Okay, so apart from that, there are n number of data sets by itself in Kaggle. Okay, you can look it and search it, and whatever you need, that just search for it and just look on the data sets. Okay, so this is my work. Okay, and this has got all the data sets that I have uploaded. Okay, so these are the data sets that I have uploaded. Okay, so I think till now it's fine, right? Okay, yeah. Go to. I'll just tell you the navigation. Okay, just go to home and yeah, and click on data sets. And then you can add a new data set, new data set. Okay, and you can just do it here. Okay, there are a lot of data sets by itself here. Okay, there are very interesting data sets. Whatever you want, that just search for data set and you will get related to computer science, education, anything is there, wherever you want. Any sort of any related thing that you have. Okay, so I'll just go to your work again. I'll just see how my data sets are. So these are the data sets that I have. Okay, so just click on one data set, open. Okay, so by itself it will show what the data set is all about. So how many rows are there, how many columns are there? So it has got 7,209, 72,923 on one sheet one. Okay, so this is a different one. The sheet one is got 72,936, 90 columns. Sheet 2 has got 16,9, sheet 3, like that. There are a lot of sheets in that. Okay, so you can go to Uh, yeah. So they just go to sheet one. So it will show like, so this is the headings. Okay. Headings. Headings are like, there is only one unique value, that is 2020-23. And we got 2 months like 0622, 0922. There are two. And others are 79%. So that others are basically the gap, the blanks, okay, blanks of the total data set. So these are where the data set, and 79% is basically the blank things. And these are the month names, June and September. And others are 79%. This will remain static because adding all these things will be the total sheet. Okay, number of rows. So you can see that dealer is another matrix or another column which has got only two variants. Okay. So one is KVR automobile, one is KVR DM vehicles. Then city has got two like that. So by here itself you can understand what all the data is all about. Right. So this is how the data is. Everything that you can find it here. Okay, from here it is actually numeric. So till here it is basically categoric, right? From here it's numeric. So just go here, and you can see this is numeric, right? Like that. So that will give the entire see of the data. Hmm?
Excel sheet itself.
Yeah, you can download it on the Excel sheet itself. Okay. So you can upload, download whatever that you want to do on the data set. Okay. And now I'll go back. So now what we'll do is that we'll see how the coding works. Okay. So what you can do is that if you want to know about what you call linear regression, so I'll just search for here. Okay. So just search for this, and you can see that there are 89,655 results, right? Okay, on linear regression alone. Okay. So you can select the by relevance, or you can select by relevance itself. So you can see that there are like 41 comments, 56 comments like that, right? So go for the bigger one. Just click here. Yeah, correct. So this is a notebook created by a person. So this guy is called Chris Doty, and 1 year ago he has got, so 16,000 views are there. Okay, so this is how he has created. So he is talking about the notebook. He is talking about the version. Then he is talking about the codes here. Okay. Okay, so I'll just give you a brief on what this code is about. First, it is like NumPy and Pandas are basically the libraries. Okay, you are calling for the importing the libraries. Okay, so you basically declare it by name. Okay, that is called NP. NumPy is NP and PD. Pandas is PD. Okay, then Matplot library is basically used for creating data visualizations. Okay. Okay, and skill learn model is also used for the linear regression model. We call for this particular library called sklearn. Okay, sklearn.linear. So we call all these libraries first. Okay. Okay, and then we declare the particular data set. Okay. So we declare the data set that train, or that is the name of the data set, that is pd.read csv, and this is the directory, or this is the link of that particular folder destination. Yeah, file name. Okay, something of that sort. Okay, so I'll just go back and show you something that I have done so that I can make it more important. So here I'll just go here. So in my work, I have some similar things. So this is something that I have done. Okay. So what you can do is that once you search for this particular sheet, right, notebook, you can go ahead and edit this and save it. Then it will be in your work. Okay, so this is something that we did, myself and Vinita did. So this is car price prediction, something of that sort. So how to increase gross retail or something like that. So I I'll go and click and edit this. Okay, I'll click and edit this. Okay, so now this is ready for edit. Hmm. So here, if you, yeah, it will show. Huh. Huh. No, no, yeah, it will be there on that particular data set. You saw the data set, right? There you can see everything. But I don't recommend using Python because it can be really initially it can be really stressful doing or editing on your sheet basically on Kaggle. Okay. Huh. Huh. Hmm. 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 Okay. Okay. So what I am telling you is that your data set, what is there is on Excel, right? Okay. What are edits that you want to do it there itself. Whatever columns that you want to change or whatever do you do everything on Excel itself. Okay. Once that is ready, then you import the data. Okay. So you can add the data here. Okay. So once your data is there, okay, you can just click on your data sets and it will come here and just click the plus button. Okay. Then your data will come to the notebook. Hope you got that right. Yeah. First you have to upload it on the data set and then you will have to add data here. The button is here. Add data. From here I have to add. Uh, Yeah, yeah. It will show on the column, and you have to put the plus sign. Okay. So once you put the plus sign, one thing is that it will come here. It will come here only. It will not come to the sheet. Okay. I'll tell you how to take it to the sheet. So here we have started with the coding. So what I've done is that I have see the Kaggle and Python will show continuous warnings on this thing on filters. Okay, when you put some filters, right, it will show your filter is on. That is a irritation. So that is why just start with ignoring this particular filter warnings. Okay. So it's just basically the same thing that you start with for we are creating any particular sheet. Okay. So now you import NumPy as NP, same thing. Pandas as PD and Matplot library as PLT and Seaborn as SNS. As Seaborn is another data visualization library. Okay, you just call this. This is the generic for every single thing. If for every single Python coding, you start with this. So you basically copy and paste it. That's it. Okay. So now you don't have to customize things. You have to just copy paste this. That's it. You don't need to customize anything till now. The whole thing like there is just copy paste. Okay, and then you what you do is that you call for the sheet. Okay. Now where you get the sheet is that if you want to put this data, then you go here. This is the source data. Just click copy here. Okay, and then you put that if you want to declare this particular data set as data set. Okay, data. Sorry, yeah, I'll use small letters. Data set equal to same thing pd dot read excel. So if it is read csv, then it will be read underscore csv. Only that is the change. Okay, and you just open the brackets and you just copy paste this. You have copied from here, right? Huh? Yeah, that's it. See this? That's it. Okay. So the same thing that I did here. Okay. Only thing is that it has to be in the quotes. So here it has to be in the quotes. Okay. See, this coming to red, right? Now, once it's red, that means that it's readable. Otherwise, it's not readable. It's going to throw you an error. Okay, so here and all, it's like wherever that you are putting the command, that has to be has to come to red. Okay, so it just if I just see this, it's not coming to red, right? Because the syntax is not right. Syntax error. So if I just put it like here, now it is red, right? So what I done is that, so see, I declare the class as the source link. I mean, whatever the source link is, right? And then when I put that, I need the header. Okay. When I just input cast dot head, because class I have already declared, right? Then cast dot head means then you will get the data here, sample data. Okay. Then you use the command like, now you use only cast because this particular data set is connected to cast. We have declared it. Okay. Now cast dot shape will give you the size of the data. That means that 15 columns are there and 72,936 rows are there. Okay. Then you can use the command like cast dot describe. That will give you the count, median, standard deviation, minimum, maximum, the percentiles, maximum, everything. So use this cast dot describe. Cast is nothing but what is the dataset name. Okay. Then we can use cast dot info where you can see that what are the number of rows here. So you can see that physical year has got 72936 non-null objects. That means that data is there for 72,936 rows. Right. So it will show how many number of rows are there. So this is a big data set which has got mainly like 72,936. Okay, so we talked about 15 rows, right? 15 columns. So these are the 15 columns. 15 columns. Okay. Yeah. Correct. 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 Hmm. Correct. Correct. And row numbers are total number of data points are 72,936. Yeah, that is a constant, right? So why this is very important is because sometime somewhere there will be a gap blanks, okay, and blanks doesn't work as a proper data set. So say for example, this is showing 72,900. That means that 36 data set is not there on customer type. That means that you will have to replace those blanks with zeros or whatever, NA or something. Okay, so this has to be constant. So every column should have the same, correct? Hmm. Correct, 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 correct. So you will have to, you can't have blank spaces. Instead, you can just replace it by zero or NA or something as per your requirement. Okay, so data types are float, integer, object. There are 64 float, and there are integers, and there are objects, and the total size of the file is 8.3 MB. That's it. Okay. So this is basically checking for the missing values. If you want to check then in with missing values, you can see that there are no missing values here, right? So use this. Correct, correct. So this is another way of checking the missing values. So what missing values total is equal to cast is null sum sums. That means that wherever there is a null, it has to add it. Okay. Okay. So just it's asking for printing total number of missing values and missing values total. Then you find the answer here, right? Missing values in this data frame is 0. Got it? Okay. So here also you can use this for missing values per column. It's null sum, so same formula that we use, so it's all zeros. So I think now it is the data set is perfectly okay for valuations. Okay. Hmm. So if you want to check any specific column, whether there is any missing values, you can use this lines of code. Hmm. Hmm. It doesn't give any instructions specifically. That maybe when you're stuck, then you can just copy everything into chat GPT and ask it what is the correct one. Okay, Kaggle, the only objective of Kaggle is to give you a data set that is connected to your requirements. Okay, so you just make a copy of it and learn everything yourself. And whatever amendments you may want to make it on that and save it. Okay. So data cleaning preparation, everything is done. Okay, missing values again that we have seen here. So now we are asking for the unique count of models in label PPL. Okay, so PPL, if you see, it is a it is basically this one. Okay, this is the models of Tata car. Like Altroz is there, Punch is there, Nexon is there, right? So we are asking, we are asking the data, which is the unique count of models for. So PPL cars is basically the data set, right? And you put a dot and call the column name. Yeah, but it will be unique. Only unique. Only unique. Okay, so here I am just calling for the data set, then I am calling for the column, and then I am calling for the unique one. So the answer will be this. Okay. Then in month, and I can use, I mean, it depends upon the data. I want to see which all months are there. So these are all the months here. Okay. And here I use the fuel type that is unique, that is diesel, petrol, biofuel, electric. So cars dot columns. These are the columns. Just learning this. Okay. You want to know the columns, name of the columns, headers. Then you will use this cadar to the columns. Okay. Now we'll use certain parts here. Okay. So what he will do is that so this is basically what do you call? We are just creating a box plot. Okay. For me, it didn't work well because in my data set, it is highly skewed data, wherein almost 95% of the data is connected to zeros. Okay. Only 5% is connected to values. So that is why it doesn't show well here. Okay. But normally, the syntax we use that use the plt dot figure, the size that you can mention as 20 bar 8, because 20 is basically the width and 8 is the height. Okay, and you can create the first subplot, that is 1 to 1. Okay, you can create a title here, and this is basically connected with the value in millions. Okay, this is a particularly a what do you call the column name. Okay, and side by side you can use the subplot as 2, and where the uh, this this is a block plot and this is a distribution plot. That's a total difference. This is a block plot and this is, but the data set is the same. And PLT show will show the thing, the box plot and the distribution plot. Okay. So now again I'll come here. So yeah. So this is another one. This is another subplot. I can mention you more here. So here again, same thing. We are using the plot dot figure size 25.6, and 131 is the first plot. Okay, 132 second plot, 133 second third plot. Okay, and PLT1 is against the fuel type, and the plot is bar diagram. Okay, so here, yeah, here we are using the bar diagram for this. Okay, so you can see, I think somebody is joining. One second. Okay. Okay. So see here, we are actually creating a blocks plot for fuel. So you mean that petrol? Yeah, petrol has got the frequency of fuel type that is the highest, that is almost like 49,000, 48,000. Then it comes to battery electric, then to diesel, and then to biofuel. So this is the distribution of how the fuel vehicle, the type of fuel vehicles being sold. Okay, into retail. So I'll just give you an idea of what this data is about. That is about a particular dealer, okay, who is selling Tata Motors cars. Okay, and he is basically see this. What is that sound? I think. Hmm. So see this, month wise, month name, dealer, city, region, yeah, fuel type, source, customer type. Green form is basically enquiries. Yellow form is basically bookings. TD done is something like it is like the what do you call when the test drive done. TD done, and gross retail is basically when it converts to this thing. What do you call business? And value in million is basically what is the value associated with that sale. Okay, so these are all the input dependent dependent variables, right? So yeah, independent variable, gross retail and value in millions will be the independent variable. So it will be the these are all the independent variables, and this will be the dependent variables, right? And based on this we are finding a relations between these, any of these and this, how it's connecting to gross retail or value in millions. Okay, so this is how, and these are all the inputs. So all these things will come in X, and this will come in Y. You got that right? So it is basically the dependent and independent variables. So we are trying to find that relation. So here, yeah. So we can find certain values like the median at the rate of 25, 50, 75. Sorry, the what do you call? We talk about what do you mean by this? We have physics terminology for this, right? Percentile, yeah, percentile, yeah. So you can see that in 25 percentile it's 0, 55, 50% is 0, 75% is 0, 85%. Correct. Till 95 it is highly skewed. Only 90, above 95 only. Rest all is 0. Okay. All these percentiles are 0. That is highly skewed data. Right? The maximum is 8.1. The median is almost like 0. The cutoff is 83.95. And you get all this data from the describe output. So you can use this for using that. So we use descriptive analytics, right? By using the count, median, then the percentiles and the quarters and everything. So you can use this. These are all the codes for that. What we do is that we do the mean value here, median value here, and the kurtosis value, right? And we put the output here. Okay, and we mention the percentiles here 0.25, 0.5, 0.75. You can mention whatever here. Okay, that is why it is mentioned all the percentiles here. Okay, use this. That is the inference here. So see, what you can do is you can use two type of things. One is code and markdown. Okay, code is for using the code, and markdown is when you want to write something. Okay, so you use the code when you add the code, and markdown if you want to write something. So here I use, huh? Yeah. So here, this is basically a code, okay? This is a code, right? When you actually run this, once again, the session is starting here. If he is free and I am free, we'll go. Yeah. Uh-huh. Correct, correct. Uh-huh. Okay, 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 okay. Right. So this is the code and this is the markdown. Okay. Here you mentioned that the plot seems to be highly right skewed, and mean is greater than the median. That the significant difference between the mean and median of the linear distribution. Data points are far spread out from the mean. That indicates high variance, and total close to 95% of the prices are 0 million. Whereas remaining 5% is between 5 to 8.1, and 8.1 is the highest in the million point. So now we'll come to this. So this is the fuel types. These are the PPL or the car models. So this will come here. You use this, and here we use the bar, and we use the column called PPL, and then we put the X label as a car model. Is basically the label, right? Uh, Correct, correct, correct. Car model, and frequency of the car model will be the x-axis, x-axis, x-axis. The label of the basically we label this, and this is basically the type, the first time buyer exchange, the type of buyer, first time exchange, additional, yeah, unidentified like that. So we just run this and we'll come to here. Okay, then we can have individual, like, so see here I am using a single box plot. Here I am putting the figure a little bit big, so now it is 25.26 point. So now the height and the width, I am using it as a subplot, and here I am using the source type as the header, as the label. Okay, and here I'm using the frequency of the source time. You can see that generated leads are the highest, like more than 35,000, and the others is the lowest. Correct, correct. Variance. So these are all the dependent yeah, variables, right? So that is one thing. So here we have histograms. Here we will try to do histograms here. So here again, it's simple because the syntax all remains the same. Correct, 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 correct. Now we will come to a little bit more, like here we have model versus average in millions. Okay, so which particular model is giving you the highest average revenue or value in millions? Okay, so that basically will tell you which model has got the highest cost, which is costing you higher, or which is giving you more revenue. So you can see that Maxon EV is giving the highest revenue. Okay, here what I've done is that I've actually grouped by average, right? Source was average. So here group by, uh, so if you can see value in millions, sort by values, bar plot, and it is basically the average value that I am trying to. Hmm? Mean, right? Dot mean. Mean is basically the average. Right, mean is basically that if you have 1 to 10, then you just add 1 to 10 and divide it by 10, right? You will get the mean, the average. Okay, so here we are using the mean statement so that we can get the average of mean. So this is another way of plotting things. Okay, and pardon me, mean values for this particular value in millions against the what you call PPL type of models. So what he have done, PPL is basically the header. Yeah. So this is PPL, that is the header, and against value in millions. So I just want to find out like which all models is giving me the highest average revenue. Correct. So say for example, this for me the sale of petrol is huge, but again if you look at the revenue, it is lower. See, it is coming to here only. See, though I am selling a lot of petrol vehicles, the average cost of the vehicle is lesser, right? So that is what. So the first chart will give you PPL in value in millions. Then you are talking about the fuel and the value in millions. Then the source and the value in millions, and the customer type and the value in millions. So that means that Nexon EV by brand is giving the highest revenue as an average. Yeah. Diesel also is giving me the highest average, and CNG is giving me the lowest average. Okay. And walk-in customer value in millions is giving the highest revenue. Okay. While others give me the lowest of revenue. Okay. Then exchange gives me the highest average of revenue. Additional give me the lowest average of revenue. And in what numerical terms, or how much that you want to, right? So one is almost like it is giving me almost like 1.2 million average revenue per car. That is how it comes like. But here, if you can see, the first time buyer is only contributing like zero point 0.5, zero point 0.05, that is 5 lakhs, 0.5. Here, if you can see that the diesel cars is giving me an average revenue of 0.08, so almost like 8 lakhs, 8.5 lakhs. But the same time, petrol car, though it's sold higher, it is giving me like 4.9, 4.8 lakhs, like that. Okay. Yeah, again, another way of doing things is that, I mean, same thing I have done individually like this. Okay. Same thing I have plotted like in the box, like in the most. Correct, correct. So here you can see that my my x-axis remains almost the same, right? Value in millions. Correct, correct, correct. So I'm just trying to understand how every single dependent variable is connected to the independent variable. So my independent, pardon me? Yeah. Uh, hmm, 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 hmm. No, see, I'll tell you. Here, this is the graph, right? This is the code. This is the code, and this is the graph. Okay. So here, if we can see that the plot one is model versus average value, and in which, uh, see, no, here you have to write it. Here, you have to put the set title here. Here, whatever you change, it will come like that. Okay. And what happens is that, see, it has basically it will show the PPL and the value in millions. Hmm. Correct, correct. What are you choosing as a name on the x-axis, y-axis? It will come as it is. The only thing that you can edit is the title. Okay, so here if I just change the title, it will change accordingly. Okay, now we will come to regression. This is one of the most important thing that we do, right? So what we do is that for that we import like statistic models. Just copy as it is. Okay, so import status model.api as SM. We put that, we call in this particular library and we give it a name called SM. So you can give any name for that matter. Okay. You import pandas as PD. Okay. Now your data frame also you declare, and that is like pd.read excel and use the source link. Okay. Then again, the same thing I have done again. Let's leave it. Okay, it's the same thing again. And now we have independent dependent, right? We declare the independent variables. So green form, yellow form, td done and constant. This is basically numbers. Okay, numbers, the number of data points. So these are the. I want to see how these independent variables are affecting the dependent variable, that is gross retail. So I just mentioned the headers here. That's it. Okay. For me, these are all the numerics, right? Rest are all not numerics for me. You just go here, data here. You can see the only these are the numerics. So that is why when cast.describe that I mentioned here, it will only give me the data of these 1, 2, 3, 4, 5 columns, because only these things are numerics for me. See, these are all categoric, right? So, so here what I am trying to understand, what we do on a regression is basically we are trying, yeah. That, okay, that depends on how you want it. Maybe see, dependent variable is just one, right? You can only plot only one, either gross retail or value in millions. That is the dependent variable, right? Because it depends on something else. That is basically the output, because you don't have any control on any of these value in millions and gross retail, because how the variations happen in GF, YF, TD done and cons, this will change. You see, the output is something that you don't have any control on. So that is basically dependent variable. And thing is that it is dependent on the independent variable, that is the GF, YF, N. So you can just remove, if you don't want GF, then you can remove this. Okay. YF, these are all the headings, right? But dependent variable has to be only one particular, as many as possible. Okay. Yeah, correct. And basically, you use X as the independent variables and Y as the dependent variables, and you just print the results. Then it will give the regression summary. Same thing. Okay. Now, what I do is that rather than going ahead and analyzing it myself, I just copy that and put it in Chat GPT, and it will give the answers. That's the best way. I'll just show you one thing. I'll just open a. Uh, I think you are not able to see the screen, right? My Chat GPT. You able to see that? Okay. Hmm. 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 Okay. Before coming to that, a little bit we can understand that this is the dependent variable, that is the gross retail. Okay. And we have used the OLS method. We have talked about the R squared and the adjusted R squared. Right? So R squared, this model, this particular model, it is only representing 29% of the data. Okay. So you mean that that is not exactly a reliable model to be specific. Since this whole model will representing only 29% of how your data is, it. But again, people take that. Okay. Mm, 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 mm. It's relevant. Okay, that he mentioned something like 40%, 30% and all. I don't know, but again, okay. Let's see how ChatGPT answers to that. Okay, okay. So here, this is the most important thing: the coefficient of regression or correlation coefficient. Okay, then you can see that the yellow form is having the highest correlation coefficient, that is 0.43. So that means that for every single unit increase in yellow form, okay, or the booking, there is 0.43 increase in the gross retail. So the statement will come like B0 plus B1x1 plus B2x2 like that, right? So the end result, that is the gross retail, will be equal to I think the coefficient of 1 second 0.314, that is the B0, that is the intersect, right? So statement will look at zero. The y that is mean that the gross retail will be equal to 0.314 plus uh, 0.005 into GF plus 0.4309 into YF. Huh? Yeah, y is equal to mx plus p, mx plus same thing, same thing. So here, that is for a single ML, single SLR. We talk about the MLR multilinear regression, then it will be like B0 plus B1x1 plus B1x2 plus B1x3, right? So here the statement will come like uh, uh, the retail will be gross retail will be y will be 0.0314 plus B1, that is like 0.05 into GF plus 0.4309 into YF, and minus, see, you can see that the test drive one is giving a negative correlation. It is not actually error. That actually means that for every single TD done, okay, there is a negative 0.024 decrease in retail sales, in gross retail. That is mean that the TD done is something that we need to actually look into, because there is some malpractice happening, because that is never correlated to sale gross retail. All these tests right just for the sake of it is being done, and if you actually don't actually notice this, the thing is that the more that you give test drives, it will diversely adversely affect the retail. Mm. Mm. Correct, correct, correct. Gross retail is basically sales of the vehicle, right? So we are trying to understand that how this sale of the vehicle is related against this. So you see that YF, it is negative. Yeah, that the so this is having a negative correlation. So if you don't actually look into properly giving that the test drive, the thing is that you're going by the old process itself, then it is going to diversely impact your retail sales. Okay, you see that YF has got a greater correlation because greater the yellow form, greater the retail, right? Booking, greater the booking means greater the retail. Okay, correct. The 1.174, right? And here you can see that the P is more than, except for GF, the other, it is all like more than 95 percentage, right? So you can see Kurtos's Qness all here. So I'll just copy paste in ChatGPT and see. So I just done it, and the R square is 0.29, which indicates the model is explained 29.8 percentage of the variance in gross retail. Okay, there is no much difference between adjust R square and R square. The F statistics, the measure of the also the higher values indicate better speed because F statistics here, if you mention here, F statistics is 1.03 to the power of 4, right? Into 10 raised to 4. So higher F statistic means that it is indicating a better fit. Okay. And the probability, a small value close to 3 indicates the overall model activity is significant. The probability of statistics also close to 0. You can see probability of statistics is 0.00. That means that it is statistically significant. Okay, the represent the GF and 0 point will come to that before standard error. There are estimates of the this used to get theta the ratio. Okay, what does this mean? I'll just again copy paste this. See, the coefficients are crucial for identifying the relationship between dependent given by the interpretation. Okay. See, the 1 unit increase in TD done is associated with the decrease of 0.052 in dependent variable gross retail. See, decrease. Right. And here you can see that the 1 unit of YF is associated with an estimated 0.4309 units. So this is the highest coefficient. Uh, Something like that. Okay. So that is how you come to here, and so you can use the other measures also. This is this I used with the I mean Excel in Microsoft Excel. There is a tools, right? Statistical tool. Yeah. Toolkit, statistical toolkit, something like that. Yeah. This is the heat map. So how you do is that again you just do that, and then here you are importing. These are all static, and here we are actually calling for the Excel, and we are creating a correlation matrix called car.core, and the size of the figure will be 10,8, and here we are using the SNS heat map correlation matrix. The annotation is true. We are using a color combination like cool warm. There are a lot of other combinations also. Okay. And line width 0.8. I don't know what this 0.2f is. I think it is basically the thickness of the this thing lines are all. And here you can see the correlation. Okay, you can see that you can see that gross retail the correlation of tele is 0.01, walk-in is 0.13, digital is giving a negative correlation 0.05, generator is giving a negative correlation, others is giving a negative correlation, GF is giving a positive correlation, YF is giving a highest correlation, that is 5.54, TD done is giving a negative correlation, and this is giving a higher correlation with the value in vehicles because gross retail is actually converted into sales, right? So this is 0.63. So wherever you see red, right, that is having the highest correlation. So this is like GF to TD done. Okay, see that this is where the problem is coming. See, these green forms are there, that is basically enquiries. This enquiries has got higher correlation with TD done. That means that every green form enquiry is actually trying to give a test drive on. But again, it is not coming to bookings. So some kind of a focus or a kind of retrospection has to be given on what kind of is it actually the needed people that we are giving the TD or test drive. Just for the sake of it, yeah, just driving, going, that's it. Yeah, you can see the TD done GF. So this is again here, gross retail and yellow form has got highest correlation. That is obviously true, right? Because when yellow form is basically bookings, Bookings has got a greater correlation to retail. Okay. And TD least is like, let's see, 0.053. The digital and the generated leads has got the least correlation. That doesn't make sense actually. Digital and generated doesn't make sense. Mainly, you will look at this particular row, right? And this particular row. These two things, because these are connected with the actual outcome, that is the uh, dependent variable, right? Correct. So, yeah, correct. Yeah. So here these are the gross retail and value in millions, and here are all the dependent variables, right? So here you can see that 0.63 is the highest correlation. So obviously, and the lowest coming to 0.05. This digital reads is never going fetching any good result to the company, because it's just spending money on digital without any correlation, because it's actually negative correlated to gross retail. Correct. Now, Saif, what we can do is that once we got this specific first level of understanding, right, that digital is actually giving a negative correlation to gross retail. Now we can take model wise digital inquiries, or location wise digital inquiries, or source wise digital inquiries, and then we doing all these processes, we can pinpoint what is actually the find the actual problem. Correct. Correct. So here we identified the problem, right? Digital is not contributed to grocery sale. Now you will have to dive deep inside. For we just filter it to digital leads only, digital data only, and then we try to figure out what is the effect of all other variables to that particular digital leads. So something like that. So this is what violin plot. Here again, it's all the same, and basically this is walk-in gross retail. We are using only two things, okay? Two gross retail, that is the dependent and independent and the dependent walk-in. Tele and gross retail. So something like that. So tele, generated, digital. Uh, correct. 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 So, see, Saif, so I think more than if I teach you, then you will be, it will be more complex to you. uh, I'll tell you exactly what you do. Okay. Okay. I'll tell you what exactly that you do. Okay. Go to any particular thing. Just search for here and go to the tab. Okay. And then what you do is that you copy and edit this. Or let me do something else. I'll just go to home. I'll go for multilinear regression. Multi. Okay. Spelling. Linear regression. Okay. So there are a lot of data sets. This I think can be zero comments. So I think I'll go for the highest. Where? Okay. Oh, this one. Okay, yeah. Yeah. So I'll use this. Okay. So I think this has got 144 comments. Just look at the comments. How is it like? It's very helpful for my first project. So wow. Okay. So it is wow. So go to notebook. Okay. And then you copy and edit this. Okay. Then what you do is that you add your own data. Before you do add a data, first you have to go to data sets and add your data. So then you will come here, your notebooks here, and just click the plus sign. Okay, here I am just putting the plus sign. Okay, and then closing this. Then you can see that it is here. And from here I copy this. Okay. And then a second. I think this is a more complicated version, I think. Oh, this is tensor and all. I don't think this is deep learning. Okay, this is this is PyTorch and you PyTorch is another PyTorch. And what do you call SkyPy and all? It's more complicated. Scientific Python, SkyPy. Okay, just don't go for all this right now. I will go for here. 13 comments. Ah. Hmm. Okay, just multilinear regression. House prediction, multilinear regression. Okay, so just copy and edit. Okay. We then add your data here, as I mentioned. Okay, your data sets. Add this. So I add this, and then I close this, and then I go here, click here. I click. This is the file. And what happens is, which all sheet that I want. This is sheet 1, sheet 2, 4, whichever sheet is there. So just click there and just copy the file path here. Okay. And then you do here. So here, everywhere, instead of this particular link, right? I just paste my link here. Okay. And then I run. Okay. No problem. No problem. So this is a big data set. That is why it will take some time. You missed import pandas. Okay. Mm. Mm. What is showing? Okay, communication byte. Okay. Okay, I think that I have to actually take care of all the. This is CSV, so that is one another thing. It is Excel. CSV is, yeah, the data sets can be in two types. One is in Excel, that is XLS format, SLXX format, and CSV is .csv. CSV is a more lighter version. So Excel will take some big space because it is again calculating all the spaces, all the what you call formulas, everything will be there on that Excel, right? So here what happens is that it will have only the concise data alone. and the data will be in a tabular format, right? In Excel, it will be on a tabular format. So how it the machine actually recognizes the how it is in different rows is just by giving a column with comma. So if A, B, C, D, E, these are the different columns. So it will be A, comma, B, comma, C, comma, D. Okay, that is how it is saved. And when you output, the just like it will be in different columns. So that is why comma separated values. That is CSV. Okay. So instead of their data, I have put my data here. Okay. So then now if I just run the head, see this data, that sheet doesn't come any data, but again all these columns will come. It is a blank data actually. Okay, so instead of I think sheet one, okay, I'll just copy this. Sheet one, copy file path. Huh? Oh, yeah. Hmm. Okay, just this. Okay. Source wise data. This Excel. For me? Ah, correct. Okay, so the display house dot head will give you the headers. Okay, and info describe number of top counts, frequency, everything will be getting. So then you will run all these codes and just see how it looks like. Okay, you do one thing. I'll just share my file. Okay, just create a copy of that and start doing some things on that. Hmm? I'll just show. Ah, 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 ah. Okay. Or I suggest you can use this one also, multi-linear regression. Right? Yeah. So columns. Set. Hmm. This is one LinkedIn network analysis I did. Okay, I'll show you data. This is the LinkedIn data set. Connections. First name, last name, URL, company, position, connection date. Okay, so we have inputted the data here, and I we can get it from LinkedIn itself. From there, you go to settings and you can download this. Hmm. So I imported the libraries, and here it's a CSV, so it's CSV here. And I just click on the copy file path here. So that is how. So see this one, right? Same here. That's the file path df.head 10. That will give me 10 rows. Yes, yes. Oh, it's there. I mean, already somebody has done this. So you only you have to edit that and copy for your own. Yes, yes, yes. See, what I've done is that I have initially run this. So I imported the pandas, Plotly Express, and Graph objects. And then what I did there, I have import. This is the 10 rows. Okay, that is why pdf.head give me 10 rows of sample data. Okay, so these are my contacts: first name, last name, URL, company, position, connected on. Okay, then describe will give me description. Yeah, the count unique top frequency. This will give me, yeah, connected. So connected on, it's just a sample data. See, this is the how my connections has gone. Like it started on 2012 and 2018 it is the highest, and then again 2023 it is going. So my highest was in 2019. So this come here on the March of 2018. I had the highest connections of 279 counts, and here see collected it. They given a color code also. Like every year it's got a color. So use this. Right, then you go here and there's another one, number of connections per year. See, 2018 I had the highest like 200, 2,373 connections. The lowest was in 2022 with only 55 connections. And here again I go here and run the command month wise. The run is, that will give me from which organization I got the highest connects. This is top companies organization in my network. This will give me, this is basically a card. Yeah, it will give you what do you call cards, connections. Yeah, yeah, cards. And this is basically the type of positions. So I got 126 may not mention connections. Founders, I got connections with 74. Directors, managing directors, like that. Right. So it's very interesting here. You have to play the data. Just go to any particular file, just search for it and start editing it with your own data. You will just get first get irritated when you are not able to connect the data. So that is why I am being very, I mean, eloquent in telling you how to connect data. Okay. Hmm. 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 Mm. 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 Okay. Mm. 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 Correct. Correct. So I think, Saif, but if you get into any kind of a stuck, just let me know. I'll try to help you out, whatever I know. Uh, mm. 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 No, 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 don't go for that because absolutely it's waste. I mean, doesn't make any sense. What I am suggesting is that you go to Kaggle, take a sample data set and work it out yourself. And if you get stuck, just let me give me a call or just go to ChatGPT and tell your sequence like, I just want the Python code wherein the x-axis is this, y-axis is this. I want to create a kind of plot, what do you call, SNS plot or a heat map or a bar or a histogram. Just give me the code for that and just copy paste right on that and just see. Anyway, you will make mistakes, but that's okay. Hmm. Correct, correct, correct. See, I was going through a particular post on LinkedIn where it was mentioning what kind of charts or what kind of models which are actually used for a particular data set. So we use decision trees. Okay, that is a different way. We use logistic regression when you got the output or dependent variables in terms of zeros and ones, yes or no, right? Right. So that is why you use logistic regression. Then we use random forest. Well, yeah, there are a lot of methods that is there. That is the so deep things. I mean, so when we know that this is a particular data set, then this is the model that we use that will give you the best results output. Mm. 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 Okay. Okay. Great. 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 All right. That's okay because for me it's I always love doing this. because it actually by the way it also improves my confidence in these things, right? Whatever. So, but again, I'll tell you, whenever you get stuck, don't. I mean, pause. Just ask. Okay. Just ask. There is always answer. I mean, I learned from scratch. I don't know anything. Still now, I don't know much great things, but I'm just little bit studying things. But now, when since ChatGPT is there and Kaggle is there, I think that I mean we can see any kind of see if you want to learn random forest, you can search it on this thing, and you can see n number of data set that is connected with that random forest or notebooks connected with the random forest. Uh, hmm. 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 Correct. Correct. Hmm. All right. At least you have done MBA. I've done nothing on that part. That is there. Uh, 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 hmm, 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 hmm. Yeah. Uh, okay. Can you just check your WhatsApp now? One second. Yeah, yeah. One second. Net was off. One second. Yeah. Got it. Now you see this. So linear regression for predicting price based on features. So that's the same thing that we did, right? Where based on the features, how the price, how is that connected? That we use linear regression to. Logistic regression, that is a spam. If it is a mail is spam, it is a yes or no. That is a binary output that is either zero or one. So that we use logistic regression. Okay, then decision trees that we use for customer churn. Churn is happening. So if there is a particular data set that connects with the churn or churn because customer churn because a lot of the people lose out. Correct, 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 correct. Segmentation we use k-mean clustering. So LSTM is another thing for stock market prediction. So it's very complicated. So we use this long short-term memory for so all these things are there. You search for Kaggle, it is there. So Chat GPT, sorry, natural NLP, right, natural language processing that we use for chatbot and customer support. We use these kind of models. Mhm. So these are all the things that I am trying to. Basically, linear regression is okay for me. Logistics till a bit, but I am just trying to figure out this random forest and decision trees. That is quite a little bit uh, complicated. Yeah. Hmm. Yeah. Hmm. Okay. Hmm. Okay. Fine. Hope this time that spent was a little bit good for you. But more than this, I can't also explain because it will be very complicated beyond this. Thank you. Have a good day. Bye.